All right, let's see if I can actually share stuff. All right, I hope y'all can see me and hear me. It's not the mic I prefer to use, but it's the mic that has been selected, so we'll live with that. And let's see if I can share my screen. All right, so let's hope that y'all can hear me. All right, I get no feedback, so hopefully this is all good. Hi, everybody. I want to thank you for having me here today. I would much prefer to be there in person. I like talking to people in real world, and I would love to be in Bogota right now. I do want to thank the organizers for the best speaker jacket I've ever gotten. So it's too hot to wear it today, but I'm definitely going to be wearing it soon. So thank you for that. Today's conversation is about security and about how security is too hard and how we could stand to automate it to make it easier for us. So let me introduce myself first. I am Sasha Rosenbaum. I started my career as a developer, and then I did some operations. I was an architect for Microsoft for a number of years, and then I'm a product manager for GitHub right now. And I can't see you all, unfortunately. I can't have a raise of hands to learn more about who you are. So I'm just going to make assumptions. So I'm going to assume that most of you are probably in operations, and maybe some of you are developers, but probably not a lot of you are in security. And so I'm kind of giving this presentation from that standpoint. So let's talk about the state of security today. So security today is what happens when you sort of bolt on the locks to your house at the last possible minute, right? And this all sounds very normal to us, but really think about like you just bought the most amazing mansion and you just got the best basically furniture, the most expensive lamps that you could get, the most expensive TV on the wall and stuff like that. And you just decided that you didn't really need to install doors because installing doors seems like something that's not really a high priority to you. So that's kind of how we approach security today. And from software reports, we basically know that the more code we write, the more problems we introduce. So we kind of are not really good at learning from our mistakes. Actually, every line of code that we add can add a new problem for us. And we also know that 53% of breaches are actually caused by weaknesses in our applications. And so actually most of the rest of them are caused by weaknesses in configuration. So most of issues come from our code. We also know that the earlier we remediated, the better. So if we can switch and shift left on security and basically have it earlier in the developer lifecycle, it would cost us less. And if we somehow make it all the way to production, it will cost us a lot more to remediate. And then if we actually make it all the way to the breach, that's millions of dollars and a reputation problem. We also know that security is not someone else's problem, right? Because if you want to tell me like, oh, Sasha, I'm a developer or I'm an ops person and I don't care about security, that's a security person problem. That's a CISO problem, right? He accepted the job. Well, we know that there's about 45 million developers in the entire world today, estimated, but only 70,000 security researchers, right? So they couldn't possibly just numbers game. They couldn't possibly secure applications. Our new approach today is actually that we want to assume breach at all times. We want to not say like, oh, our company is secure, our applications are secure, but actually we know that we are going to be a target of attack, and we're probably going to be hacked at some point in time. So I'm not sure who said it first. The quote is attributed to multiple people, but basically it says there are two types of companies: those who have been hacked and those who don't know that they have been hacked yet, right? So what do we do with all of this information? This sounds pretty scary, right? So first advice is don't panic. So this is my favorite slide, so I usually just look for some ways to use it. So basically, the first thing we want to start with is protecting credentials. We know that most breaches are actually caused by two things. One is credential theft, and the other is exploiting known vulnerabilities. So these are the two widest open doors that we want to secure. So there's a lot of numbers on this slide, but I want you to focus kind of all the way on the right. So basically, nearly 50% of people open phishing emails, and then 99% of exploited vulnerabilities were compromised more than a year after a CVE was published. And we're going to talk about that number a little bit later. But let's talk about phishing right now. So this is a phishing campaign that happened at Microsoft back when Windows Phone was still a thing. So people were promised a free Windows Phone, and actually 41% of people clicked on the link in the email. And these were smart people. These were Microsoft engineers, right? And most of them clicked on the link. And we know that employee awareness training is not very effective at preventing this kind of thing. So usually phishing attacks are successful, at least for some percentage of our employee population, despite the education and training and all the things, right? So this may sound mundane, but if there's nothing else that you can take from this talk today, please take this with you: enable multi-factor authentication. So on every possible platform that allows you to enable multi-factor authentication, please go ahead and enable it. I know it can be annoying. I know it can be frustrating to be prompted for multiple signs in on multiple devices, but this means that if an attacker got your credentials were compromised, he's not going to straight up gain access to your production servers, right? So multi-factor authentication is one of the biggest automated tools that can help you protect your servers. And then also there's email protection. So almost every email provider today enables some type of email protection. So kind of filtering out phishing links automatically and things like that. So again, something that if you are an Exchange administrator or an email provider administrator of some kind, please enable that. That really helps. Now, let's shift gears and talk about securing your software supply chain. So a question, and again, I can't see you all, unfortunately, but how much do you think you rely on open source? Well, we know from software composition reports that 99% of organizations make extensive use of open source, and 90% of application development leverages open source software. So we actually really write really tiny percentage of our business logic, and everything else comes from other people's code, primarily open source libraries. And that's okay. That's actually good, because that means that we don't have to implement date and time every single time we implement a new application, right? That's cool. But it also means that we have tons of dependencies, and a lot of dependencies we're not even aware of. So when you run that npm install or NuGet install, right, and you get all these loads of packages, that's what happens, right? It just brought all the dependencies that you got. And that means that somewhere in that dependency tree, there could be a package that is vulnerable. And the worst case scenario is that it has a known vulnerability. And again, coming back to that number, 99% of exploited vulnerabilities were compromised more than a year after the CVE was published. CVE means common vulnerabilities and exposures. It means advertising a way someone can break the lock, right? So you have a certain type of lock, you have a certain type of software package, and now hackers have identified, or security professionals rather, have identified a way that this package can be compromised, that lock can be compromised. And then they publish it as a public service announcement that package is compromised, right? But you don't go and change the locks. Why don't you go and change your locks? Well, you're too busy to buy new furniture for your house. And you're like, oh, okay, sure. I don't really have to change my locks. Who's going to use that vulnerability? Well, actually, hackers do hunt for these vulnerabilities all the time and compromise software using these vulnerabilities. So we know the more recent report is 90% of active applications use libraries with known CVEs, and 30% use a library with a critical CVE, meaning that I could do something like get into a database and drop your tables or something like that. And then patching a critical CVE took an average 34 days. And we know that for open source software, that number is actually higher. It's close to 100 days to remediate something. Now, the problem here is that it's actually really hard to remediate vulnerabilities, right? It's not that easy to get and identify what's been compromised, what CVEs have been published, which packages you rely on. You may have hundreds of applications. It's difficult. So that's where automation comes to rescue. There's a bunch of different products on the market. GitHub has one of our own. I'm biased, so I'm going to talk about that one. So basically, it helps you automatically identify vulnerable packages, and then it helps you also to create automated pull requests to remediate those vulnerabilities. So you actually get an ability to just click a button and upgrade a vulnerable dependency. And because it's a pull request, you can do a code review for that, and you can run your tests and make sure that everything is compatible and everything works okay. Now, this exchange happened on Twitter a couple of days ago. I'm not going to quote who it came from because these are real people working for real companies. But basically, yes, it can get you can get alert fatigue from even just enabling the software. But here's the truth. The truth is that hackers don't sleep. Hackers who are going to attack your company are actually going to use these vulnerabilities against you. So at least you can use the software that helps you remediate the issues, which is, again, a lot easier than doing it by hand and just scanning the CVE reports. And we know, again, from looking at internal data, that Dependabot increases the resolve rate and speed for these known dependencies by a lot. So kind of in terms of package management, you want to scan your open source dependencies. You want to make sure that your own build artifacts are managed. So kind of track all the builds from everything that passes the test, that it's exactly the same library that makes it into production. And then also that your binary artifacts are consumed from trusted feeds. So instead of pulling public NuGet, maybe consider defining your own internal package source and pulling from that. And then you can sort of gatekeep at that point and make sure that only non-vulnerable packages make it in there. Let's shift gears again and talk a little bit about securing your code. So one thing that I want to just briefly mention is secret scanning. So people commit secrets into source control all the time, sometimes on purpose, sometimes by mistake, sometimes into public repos. You want to have software, ideally, that scans for secrets. So basically, you can identify and flag those secrets, and you can make sure these secrets are revoked. And also, you want to use secrets that are basically used by your application at runtime instead of being put into source control of your application. Now, I want to talk about code scanning. So this is your basically code scanning software that allows you to do static code analysis. Now, again, this software is not ideal yet, but it's made large improvements in the last couple of years. It's actually getting more effective by day. So basically, you think about the case, and again, we said more code, more problems, right? So think about me writing a little procedure that says, okay, I'm going to pull something from a database, right? And someone else goes into a different code file and they commit a code that says, okay, that parameter now comes directly from outside sources in an API call. Now, we may be on different teams. We may be working on different parts of the software. We may not know that this trace even exists, or we may not know that this is a problem, right? So wouldn't it be nice if we had software that helped us identify this and catch this before it goes all the way to production? Well, such software exists. So you can use static code analysis to scan your code and identify this type of problem. And basically, the hardest problem with that is that people don't actually use that much of it. So if we look at people who use static code analysis, only 5% of those people use it weekly. Most of the people you can see use it only once a year. And then less than 1% of people use it daily. So, and that's only of the application that actually uses static code analysis, right? So the situation here is pretty bad. We're actually pushing code to production without knowing if it's secure or not. And so our pipe dream at GitHub is that the static code analysis will be part of your pull request system. So once you check in code, instead of just me, Sasha, looking at your code and making sure that that buggy line or that security vulnerability doesn't make it into prod, I can rely on an automated tool to code scan and to prevent that PR from going live. And then I can check every commit, and I can also periodically run it on my main branch to make sure that everything looks up to date. And the benefit of that is that sometimes it catches bugs that you wouldn't even be aware of, right? There's some obscure circumstances that you don't even think of that a software can catch and prevent you from exposing your application. Now, automation is sweet, but automation isn't everything. I'm going to quote Rain, who says, I mean, yes, automation eliminates human errors in the sense that those errors will now be performed by machines. So yes, automation can scale out your errors so now they perform quicker and more reliably by lots of machines, right? So there's still a lot of parts of security that can't really be automated and that I would advise to still use and on a human level, right? So one of them is threat modeling. So again, our biggest problem is that developers think about how the product works, right? When I implement a feature, I think about the intended usage of the feature. When an attacker comes and wants to hack into my product, they think about the exact opposite. Every single possible misuse of the feature, how can I break into it? So threat modeling usually, and there's some tools for that too, but usually involves a big whiteboard and people basically looking at different scenarios and trying to see if there are scenarios where people could break into your software and how you could potentially protect against that threat. So that's a very useful exercise. Kind of a limitation of that is that you can't do it for every single line of code because you would be doing it all day. But it's really useful to do for like major features of product release. And then this is my personal favorite. So this talks about war games. Again, we want to switch people's mindset, right? Defenders think in lists, right? I went through a security checklist, that must be fine. Attackers think in graphs and they break into software layer by layer. So one of the things, again, this story comes from Microsoft. So basically Microsoft introduced on multiple products, introduced something that's called red teaming. And basically we started doing these exercises where we would pull some of the developers into a red team. By the way, this was one of the most popular assignments in the world. People just really wanted to be a part of the red team. And basically started playing these war games where we had a red team and a blue team, and the red team would be attacking our software. And that taught people a lot about how hackers really think, and that taught them to be better developers. And over time, we actually eliminated the blue team because, well, in the real world, the hackers don't usually send you warning when they are about to hack into your software. And then we started focusing on some things that are more realistic attacks. But basically, what it teaches us is to block lateral movement. So a typical use case is a red team attack that goes into, okay, we found some file share that's on the network that was unprotected because it was considered unimportant. Then we found plain text credentials on that file share. Then we got the test account from that and got a local admin into a dev box that, again, was considered unimportant, so it was just hanging out there. Then we used the tool to dump the credentials and get dev credentials for that box. And hello, these same credentials actually worked for a production machine. And now the hacker is all the way into production. Now, if you think that that didn't happen inside a company like Microsoft, it definitely did. And in the beginning of the Red Team games, actually, we found a lot of things that on internal shares that looked like that. So definitely a lesson learned in here and something that really changes the mindset because no one wants to be a part of that email. Now, this just for fun bits. We wanted people to actually prove that they have hacked into something and do it without being disruptive to customers. So people did fun things like that. That's one of my favorites. So basically, the red team created a work item that said we need to fix the cross-site scripting vulnerability, and then basically every time anyone logged into the dashboard, they actually upvoted working on that feature. So kind of lessons learned from that is assume that layers before yours will be breached. Never assume an internal service is unimportant. Never assume the service is secure just because it's internal. Your network boundary is not everything. And try to avoid standing permissions. Try to use just-in-time tokens and just-in-time credentials when you can. And do infrastructure refresh. So cloud and containers really help with that. Blow away your infrastructure frequently. It helps you to prevent hackers from sort of camping in your servers and trying to continue that lateral movement. And then again, one of my personal favorites is just conducting internal CTF. So CTF is a capture the flag game where people get to actually try to break into intentionally vulnerable application and score points. That teaches you a lot about how to not develop software. So you go into there and you start breaking it and you're like, oh my God, I have done this before, right? So it kind of teaches you to think about some use cases that maybe you weren't aware. So that's it for me today. Stay safe, and thank you so much. I can be found on GitHub and on Twitter as DivineOps, and hopefully this went okay for you because I literally can't see anyone. So hopefully I can see everyone sometime next year or sometime soon.
Thank you so much for your presentation. For your presentation, it was a pleasure to send you the jacket. I know you like it.
Yeah, it's great. I wish you see I'm sweating right now. So no jackets for me today.
Okay, thank you so much. We hope to have you next year in the event. Ahora vamos a pasar a la presentación de Carlos Carrero desde la ciudad de Medellín.